Okay, hi, geometry kids. This is Miss Karapetian here. You can't see me, but you hear my voice pretty much like normal. So today we're going to be doing lesson 4.4, and it's kind of going to be a mix, okay? If you remember when we did lesson 4.1, translations, last week, if you would actually believe that, we kind of ended here right after we talked about rigid motions and how rigid motions preserved length and angle measure, aka they pretty much kept shapes congruent, right? So like this triangle is the same triangle as this one, just slid over, that kind of deal. And then we stopped right here and I said, you know what, we're going to come back to composition transformations. Well, that's lesson 4.4. So I want to start with the end of lesson 4.1 here. And then we're going to work our way over to lesson 4.4 over here. Okay. So some materials you're going to need for today when we get to the 4.4 note sheet is you will need some more of this awesome parchment paper. So if you have any patty paper or parchment paper at home, please go ahead and maybe cut some more for yourself. Or if you're an artist and you have any of that like see-through paper that you can trace with or tracing paper, um, that'll work too, right? The whole idea is that you can trace it on here and then kind of move the shape around. Um, so I again went and I cut off like a sheet of like parchment paper and then cut it up into like little square-like shapes. So nothing fancy here. All right, so let's get started with talking about compositions. What is a composition? Okay, so once again, we are starting at the back of the notes for lesson 4.1. Okay, so make sure that you're on the back. This is the back of 4.1. Okay, so this is 4.1 back here. So you want to start there. Okay. And then we're gonna talk a little bit about here, and then we're gonna move on to 4.4. Here's another thing about this video. This video is actually great because we're about to review for our test, and this is actually going to help us review all three of our rigid motions. So we'll talk about translations. Again, we'll review them. We'll talk about reflections, and we'll talk about rotations. Yay, us. Okay. Sorry, you didn't need to hear that really weird yay, us. But anyway, moving on. Okay. Um, so what is composition? What is the composition of transformations? Okay. Well, composition transformations is when two or more transformations are combined to form a single transformation. Okay. So the composition theorem says that the composition of two or more rigid motions is a rigid motion. So if I do a translation and a rotation, okay, a translation gives me congruent shapes, a rotation gives me congruent shapes. Therefore, at the end of a translation and a rotation, I would still get congruent shapes. Okay? So over here, what we're talking about here in a composition is if we do two or more transformations. So I can do a combination of any three of my rigid motions. I can do a translation and a rotation, or a translation and a reflection, or I can do a reflection and then a rotation, or I can do a rotation and then a reflection, a rotation and then a translation. So it's like one after the other. And if you remember, when we do a transformation, whether it's a translation, rotation, or reflection, right? Our image. So this is our pre-image here, our segment PQ here, right? This would be our pre-image. Okay, and then when we do translation one here, kind of. So when we do translation one here, it brings us to P prime, Q prime. So this is our image. Okay, this is our first image. Okay, but then we do another transformation. In this case, like let's say we do translation number two, right? This brings us to the second image. So I want you guys to pay attention here, right? Our pre-image is segment P2. And then after the first translation, translation number 1, it becomes segment P prime Q prime, right? And then we perform another rigid motion. Now look closely at the P and the Q here. We have P, and we call this double prime, Q double prime. So this is P double prime, Q double prime. It's that segment right there. Okay? So every additional transformation that you do, you add another little apostrophe there. Okay? And you call it double or triple or quadruple or quintuple. Right? Now we won't do that many. With translations, however, it is pretty cool because you can do 2 translations, and then you can actually write like a composition translation that would get you from point A to point C in one fell swoop, right? So it's kind of like when you do, when you get out from home and you drive to one store and then you drive to another store and then you go to the movies, right? So driving to store number 1 is translation number 1. And then driving from that store to the next store is translation number 2. And then driving from the second store to the movies is translation number 3. But if you got in your car from home and you drove straight to the movies, that would get you to the same end location, right? Without making all those other pit stops. Granted, your work wouldn't get done, but hey, okay? So when we do a composite transformations, we want to make sure we are doing one thing after another. Okay, so let's look at this example here. It says graph segment RS with endpoints R at -8 and 5 and S at -6 and 8. And then its image after the following 2 translations. Okay, so I'm going to start by graphing segment RS in purple. Okay. And then I will do segment, the first translation in pink. So this is going to be our R prime, S prime. Okay, our R prime, S prime. And that'll be I'll do that one in pink. And then finally, to do the last translation, I will do that in blue with R double prime, S double prime right there. Okay, so we'll get that segment there. So let's pay attention to what we have here. So our pre-image here is R at -8, 5. So our graph here, if you'll notice, here's our y-axis, here's our x is already in the negative area here. So -8, okay, and 5 up. So we have -8, and then we have 1, 2, 3, 4, 5. Okay, and I'm going to name that point R. And then I have S at -6 and 8. So that's going to be at -6 and 8. So 1, 2, 3, 4, 5, 6, 7, 8 right there. Okay. So there is S, and I'm going to connect these so that I have my segment RS. Okay. Now, translations review, ladies and gents. Okay, so our first translation is XY to X plus 5, Y minus 2. Okay, so if you remember what these mean, right, these are essentially our horizontal and our vertical components of a vector. So if I'm adding 5 to X, that means I'm going 5 to the right. And if I'm subtracting 2 from Y, that means I'm going 2 down, right? So the sign indicates the direction. If it's X, that means we're talking right or left. If it's Y, we're talking up or down. So over here we have 5 right, 2 down. Okay. Since we're mainly graphing here, right, I just need to move my segment. So I'm going to take each one of these points, 5 right and 2 down. So 5 to the right, I'm going to start with R. 5 to the right is 1, 2, 3, 4, 5. And then 2 down, 1, 2. here is R prime. Then I went 5 to the right and 2 down. And I'm going to move S the same exact way. So I have 1, 2, 3, 4, 5 to the right and 2 down. Here is S prime. Okay. So there's S prime. So here's my R prime, S prime segment. I've moved my segment from here, slid it down. I slid it 5 to the right and 2 down. Okay. Next, we have our translation number 2. Now, translation number 2 is the following here. We have x minus 4 and y minus 2. That means if it's x minus 4, we're going to go 4 to the left now. And then y minus 2, that means 2 down again. Okay? But here's the thing. I don't go back to the image. I don't go back to the pre-image. Okay? I don't go back to the original when performing my second translation. Right? Just like if you drove a car to store number 1, you wouldn't drive the car back home and then drive it to store number 2. You would continue from store number 1 to store number 2. So over here, now for this translation, the R prime S prime has become my pre-image, and this is going to be my image now. So once I move my R prime S prime 4 left and 2 down, I will get the image for this pre-image now. Okay, so now I'm moving my R prime and my S prime. So R prime, we're going to go 4 left and 2 down. So starting at R, we have 1, 2, 3, 4 to the left, and we're going to go 2 down. That's going to get me R double prime right there. Okay. Sorry if my hand was blocking that. And then S as well, S prime as well, 4 left, 2 down. So 1. So again, when I'm on the point, it's 0, right? 1, 2, 3, 4 to the left, 2 down, right there. There's my S double prime. Okay? And there you go. This is the end result. R double prime, S double prime. That is the end result of these two translations here. From here to here, okay? We went from the original RS to R prime, S prime, to R double prime, S double prime. Okay? So we could technically, right, like as I was saying earlier, like you could go straight to the movies from your house instead of stopping by the 2 stores. So I could cut out the middleman here and just look at our segment RS to segment R prime, R double prime, S double prime. So what would be the rule if I were to go from segment RS to my finish line of R double prime, S double prime? For that, all I got to do is actually like just count, right? How many steps it would take me. So over here, ignoring the middleman and ignoring my middle stop, I just want to go from where I started to where I ended. And for this one, I can count. Let me grab a color that we have not used yet. Maybe orange? Here, let's try orange. Okay, so if I take a look here, right, if I'm just going straight from the purple, our segment RS to segment R double prime, S double prime, that's actually the question for number 5. Write the rule for the single translation. Okay, so I want to know, to get from R to R double prime, how much do I have to go right or left, and how much do I have to go up or down? So over here, if I take a look, R double prime is aligned right here. So that means I'm doing this and I'm doing this, right? And then the same thing for S, this and this. So I went this way and this way. Okay, I went to the right and I went down. So how much did I go to the right here? I went 1 to the right. Okay, so if we're talking to the right, that means we're talking X, right? So our rule, we're going to have X, Y. okay? And then we're going to have, what are we adding or subtracting to x? What are we adding or subtracting to y? So if I went 1 to the right in my x, 1 to the right in my x, that means I'm going to add 1 to x. And then from this, I go 1, 2, 3, 4. That's a 4. Okay, so that means for the y, I'm going to have a 4 here. But is it a plus or a minus 4? Well, we went down from r to r double prime. We went down, so it's going to be a minus 4. And that's going to be our rule that will take us directly from segment RS to segment R double prime, S double prime. Okay. All right. I want you guys to try this one on your own. Okay. And I'm going to ask you for the rule. Okay. At the end. So so then go ahead and answer the question for the rule that would get you from RS to R double prime S double prime if you were to go do these two translations here. Okay. Okay, so hopefully you got R double prime and S double prime in these positions here, and you answered the points correctly, where R double prime is at -5 and 3, and S double prime is at -3 and 7, okay? So go ahead and now work on number 7, where it's asking you to write the rule for the single translation from RS to R double prime, S double prime, okay? And I'm saying double prime, by the way. Okay, so now that you've given me what rule you think it was, here it is. Okay, so hopefully you got x plus 3 comma y minus 2, because we are going 1, 2, 3 to the right, and 1, 2, right from here, 1, 2 down. So we go plus 3 to show that it's 3 right, minus 2 for the y to show that it's 2 down. All right, guys. So now we're going to flip over to our 4.4 notes. Now, in 4.4, what the difference between 4.4 and 4.1 is that in 4.4, we combine compositions of all three rigid motions. So we can do a mix. It doesn't just have to be translations and translations. It can be any of the three that we choose to combine, okay? So for our objective here, we want to understand, right? I will be able to perform compositions of rigid motion transformations. So that's talking about translations, rotations, and reflections. I just realized that I'm saying this and not showing you. So there you go. I will be able to perform compositions of rigid motion transformations. Okay. So what is a composition of rigid motions? So a composition of rigid motions is when we combine two or more, when we perform two or more transformations of translations, rotations, or reflections. Okay, so when we combine two or more translations, reflections, or rotations. Okay. How does each rigid motion affect the length and angle measures of the figure being transformed? Okay, so remember, rigid motion keeps everything the same. So each rigid motion preserves, aka keeps the same lengths and angle measures. So the figures are congruent, okay? Keeps the figures congruent. Let me close that up there. All right, so, okay. So when we do compositions, we do one transformation at a time. Okay, we don't try to do it separately. We do one transformation at a time, okay? So we want to pay attention to exactly what the transformations are. So we have a trapezoid here. It says rotate trapezoid ABCD 90 degrees counterclockwise about the origin. So the first thing we want to do is we want to list the coordinates of A, B, C, and D, okay? Because that's our starting off point. So A is at, so we're going by ones here. So I'm gonna give you, go ahead and pause the video and list the coordinates for A, B, C, D. So you should have gotten A at -7 and 6, B at -4 and 6, C at -2 and 1, and D at -7 and 1. So all I did was write down the points where A, B, C, and D are, okay? So now we are rotating this. So we want to rotate the trapezoid 90 degrees counterclockwise. So this is where we can grab our parchment paper here, okay? And that's going to help us out a bit. Remember, we want to trace the axes because we're rotating it around the origin, right? It said about the origin here. So we want to make sure we know exactly where the origin is. And we want to make sure we are notating where our points are. So here's A, here's B, here's C, and here's D. Okay? You can draw the whole shape. You can do the whole trapezoid here. There's nothing wrong with that. But in reality, what we care about is the points. Not gonna lie. Okay? So 90 degrees counterclockwise means we're turning this way toward the left. Okay, counterclockwise, right? A clock moves this way. Okay, we're doing counterclockwise here. So I'm going to take my patty paper and I'm going to rotate this and I'm going to realign my axes here. And the whole idea is I want to mark what these points are going to be. So C is going to be right here. That's going to be C prime. Okay, oops, lost my spacing there. D is going to be right over here. So that's going to be my D prime. Okay. My A will be right over here. So that's my A prime. And then my B will be right over here. That's my B prime. Okay. Oops. So I'm just marking the points here. The other thing you could absolutely do is use the rules, obviously. Okay, so right before this, we talked about rotations. So 90 degrees counterclockwise here. 90 degrees counterclockwise. Our rule is -yx. Okay, -yx. So if we're doing 90 degrees counterclockwise, that means each one of these points here, x comma y, is switching and becoming -y comma x. Okay, so what does that mean? That means this x and this y switch. Okay, and then whatever I have in my original y's changes its sign. So my x's are going to come in and they're going to be my y's here. So I'm literally just going to bring them over. All these x's, I'm going to bring them over here. -7, -4, -2, -7 again. And then my y's, I'm going to put in the x's position, but I'm going to change their signs because it's a negative. So positive goes to -6, -6, -1, and -1. And if I actually check my points here, I do get that. A prime is at -6 and -7. B prime is at -6 and -4. C prime is at -1 and -2. D prime is at -1 and -7. Okay? So that was our first transformation. Now we're going to take trapezoid A prime, B prime, C prime, D prime, and we're going to reflect the trapezoid across the x-axis. So x-axis is this one right here. Here's our x-axis, right? So we are going to reflect this across the x-axis. So you could actually do this with your patty paper if you wanted to, and you just kind of flip over the patty paper like along the x-axis, or you could just bring it and you could fold it. So right along the x-axis here, you could just fold it along the x-axis, and it shows you exactly where it would end up, right? That's a little hard to like mark the points though. So if you remember when we talked about reflection in 4.2, reflection across the x-axis, our rule is that every point becomes x comma negative y. So the y changes its sign. The y is changing its sign here, okay? So that means our rule for this reflection across the x-axis is that every single one of these points is going to become x comma negative y, aka the y changes sign. But again, just like with the translation compositions, we don't go back to the original. We don't go home. We continue from the store. So the points that we're starting with here are the points that we got for our prime right here. So it's going to be -6 comma -7, -6 comma -4 for B prime, -1 comma -2 for C prime, and -1 comma -7 for D prime. That's what we're starting with here, okay? And so when we're talking about our reflection here, notice the rule says that the x's stay the same. So I'm going to bring my x's right over here to the x's. So -6, -6, -1, -1. My y's, however, they're going to change their sign. So they're changing signs again. So this says -y. Again, that means we're changing the sign. So if it's a -7, that means it becomes a +7. If it's a -4, it becomes a +4. If it's a -2, it becomes a +2. If it's a -7, it becomes a +7. Okay? And if we really look at where my figure would land if I reflect it across the x-axis, it lands in the positive y's, right? So it makes sense that my y's would be positive here. So then I can just easily graph these here. So I have -6 and +7. So 1, 2, 3, 4, 5, 6, 7. This is going to be my A double prime. Okay, my B double prime will be at -6 and 4. So -6 and 1, 2, 3, 4. Here is my B double prime. My C double prime is at -1 and +2. So here's my C double prime. And my D double prime is at -1 and 7. So right along the same level as A double prime, so D double prime. And here you go. That is my reflected trapezoid. Okay, so we did a 90-degree counterclockwise rotation, and then we did a reflection across the x-axis, and our trapezoid went from here down to our quadrant 3 with a rotation here. Okay, and then we reflected it across the x-axis and it came right up here. Okay. The next example, we're doing the same exact transformations. So if you'll notice here, we're going to reflect the trapezoid across the x-axis, and then we're going to rotate the trapezoid 90 degrees counterclockwise. Okay, this should be primes. Okay, But notice the order has changed. The question is, will our trapezoid end up in the same ending position, right? If I went to store number 2 and then store number 1, right, would I end up in the same position? So we start again with our trapezoid, and it's in the same exact position. So we're starting with the same exact starting A, B, C, and D. So I have my -7 and 6, -4 and 6, -2 and 1, and -7 and 1 for my D. Okay? But again, I'm reflecting first now. Very important. I have a reflection across the x-axis, right? This is the regular ABCD. There's some typos in here. I'm sorry about that. Okay, so I want to reflect first. So I'm going to take these points, and I'm going to reflect them across the x-axis. The rule doesn't change just because the order changed. My rule is still a reflection across the x-axis means I take my point and I change the sign of my y. So I'm going to do that. I have -7 and -6 now. I change the sign of my y. -4, +6 becomes -6. -2, +1 becomes -1. -7, +1 becomes -1. So all I did was use the rule for a reflection across the x-axis to get my new coordinates. Okay, so what that's going to get me is that's going to get me my points here. This will be my C prime. This will be my D prime. My A prime is at -7 and -6 now, so 2, 4, 6. Here's my A prime. And then my B is going to be at -4 and -6, so 2, 4, 6. Here's my B prime. Connect my points. Oops, went a little too far there for the C, but it's okay. There's my reflected trapezoid now. Okay? There it is, right there. Now I want to rotate my reflected trapezoid 90 degrees counterclockwise about the origin. But remember, again, I'm starting here, right? I'm starting from this end point right here. So my points that I'm starting with are -7, -6, -4, -6, -2, -1, and -7, -1. But the rule for a rotation 90 degrees counterclockwise hasn't changed. It's still the same rule. Every point becomes a flip of my x and the y and changing of this coordinate right here, changing the sign. So every single one of my points is still xy becomes -yx. So I'm going to take all my x's and I'm going to put them in for the y's, because they're flipping, right? So I have -7, -4, -2, -7. Then I'm going to take the y's from here and I'm going to put them in for the x, but I'm going to change their signs. So I have a -6, which means it's going to become positive. -6 becomes positive. -1 becomes positive, changing the sign. -1 becomes positive. That's what this negative means here. It means change the sign. It doesn't mean that it has to be negative, because a negative becomes positive, right? So then I can plot these points. Notice the x's are now in the positive. So this is going to end up being at +6 and -7. So 2, 4, 6, and then -7. 2, 4, 6, 7 down. This is going to be my A double prime. Oh boy. I'm already in a quadrant I wasn't in before, right? So that's A double prime. B double prime is at 6 and -4, so that's going to be right here. Okay. C double prime is going to be at 1 and -2. Here is my C double prime. And then my D double prime is at 1 and -7. Dang, that looks way different. Okay. So let's take a look at this big picture. When we rotated first and then reflected, we ended back in quadrant 2. When we reflected first and then rotated, we ended in quadrant 4. Okay? So this brings us to the conclusion. The order of a composition matters. Okay? It matters. Okay? Each rigid motion should be done from the previous. Okay? It is a continuation. It is not a go back home and then drive back. You didn't forget anything. Just keep continuing on the road. Okay? So if we take this to the back here, we have a few more examples that we want to do. Okay, we want to really get this down. We really want to get this down. Okay, so this is where you'll be asked a few questions right along the way. So I will do this one here. It says graph the following composition of transformations. We want to reflect across the y-axis, and then we're going to translate along the vector component of -2, 7. Remember vectors, right? It's the same thing as the rule, but without the x and the y. But this -2 is the x component. This 7 is the y component, right? And we can see it's a vector because of the little arrows here. Okay, so reflect first and then translate. Oh boy. Okay, so the first thing we need to do is we need to list our coordinates. Okay, so we need the coordinates for S, T, and U. So here's my S. S is going to be at 2, 4, 6, 8, so -8. And 2 down, so -8, -2. T is at -2 and -1. And then my U is going to be at, it looks like 1, 2, 3. So -3 and 1, 2, 3, 4, 5, 6. Okay, -3 and -6. Lots of negatives here. Okay. All right. So if I'm reflecting across the y-axis, here's my y-axis right here. So I'm reflecting this way. Okay, that was really fast. I'm sorry. I'm taking my triangle and I'm reflecting it across the y-axis. So the rule for reflection across the y-axis is that each point, okay, remember, whatever axis we're reflecting across, that's the coordinate that stays the same. So if I'm reflecting across the y-axis, my y stays the same. The x changes sign here. This is a reflection, okay? That's different than a rotation. So for each one of my S points here, I'm going to change the sign of the X, keep the Y the same. So I'll do this in pink here. Okay. So my S prime, change the sign of the X, keep the Y the same. So we start off as -8. That means it'll be a +8. And keep the Y the same, so -2. My T prime, change the sign of the X, keep the Y the same. So that's going to be 2, -1. And then my U prime, 3, -6. Okay? Graph these guys. Okay? So we'll have 8, -2. So 8, so 2, my eyes are really bugging here because these lines are not that nice and dark. 2, 4, 6, 8. And then down 2. This will be S prime. T will be at 2 and -1. This is going to be T prime. And U will be at 3 and -6. Is that the right line? There we go. U prime. Okay. There is my reflection across the y-axis. Okay, and then we have our second transformation, which is going to be a translation along the vector component of -2 and 7. So vector component of -2 and 7, okay, means I'm going to go 2 which way and 7 which way. Answer that question right here. So if you said that you are going 2 to the left and 7 up, you would be correct. Well done. Okay, this is the same thing. Remember, our vector component is the same thing as saying the rule of x minus 2 and y plus 7, right? Which means we can take each one of our points here and we can subtract 2 from x and add 7 to the y. So 8 minus 2 is 6, -2 plus 7 is 5, and that would give us our s double prime. 2 minus 2 is 0, and -1 plus 7 is 6. So that would give us our t double prime. 3 minus 2 is 1, and -6 plus 7 is also 1. So that would give us our u double prime, okay? Or I could count. So if I were to start from s prime here and go 2 to the left, I'd have 1, 2 to the left, and then 7 up would be 1, 2, 3, 4, 5, 6, 7. And this would be my s double prime, which is exactly at 6 and 5. My t here, 2 to the left, 1, 2, 7 up, 1, 2, 3, 4, 5, 6. Wait, that should be, did I count way too many here? Nope. Okay, hold on. 2 to the left and 1, 2, 3, 4, 5, 6, 7. Sorry, miscounted. T double prime right there. And then U, 1, 2 to the left, 1, 2, 3, 4, 5, 6, 7. There is U double prime at 1, 1 right there. Connect my triangle points, my vertices here, and bam, right there. There's my translation. All right. Okay, you have 2 more examples here. I'm going to ask you questions, specific questions about these examples. So please take some time, complete these guys, and answer the questions that I'm about to ask. Okay, go ahead and complete your exit slip and your homework, and come to class ready to do our review assignment on Monday. Have a great weekend, guys. Take care. Be safe.